Percussion welding. Percussion welding is PEW is a resistance welding process wherein the coalescence is produced simultaneously over the entire area of the abutted surface. So, we are talking about this by heat obtained from an arc produced by rapid discharge. So, there will be an arc which happens which is rapid discharge. So, the important terminology here will be rapid discharge of electrical energy with pressure precursively applied during or immediately following the electric discharge. So, this is also part of a resistance welding process where there is a heat which is applied, then you have a flat plate, a moving plate, it tries to hit and then try to weld. So, the principle of operation is almost the same. Clean the workpiece, arc is struck, weld forces are applied and then the welding happens. The advantage and disadvantages are clearly written. The application are, it is exhaustively used in aluminum and aluminum alloys. Please see if the resistance welding process is exhaustively used for thermal conducting material. For highly thermal conducting material, we will always go for this resistance welding process, or we will try to go for a welding process wherein which we use an intermediate phase without affecting the parental material. So, primarily used for aluminum and its alloy. It is also used for copper alloy, low carbon steel, stainless steel, copper to molybdenum. It is for similar and dissimilar material, joining can happen. Welding process produces coalescence at temperature below the melting point of the base material being joining. So, you have material A, you have material B, it can be similar, it can be dissimilar, okay, joining between these two, where this temperature of the weld, it is less than the melting point of the parental material. The weld is carried out without the addition of a filler, but with the application of pressure. The next classification of welding process is solid state welding. A solid state welding process produces coalescence at temperatures below the melting point of the base metal being joined. The welding is carried out without addition of a filler material, but with the application of a pressure there. At least one of the material should have highly ductile and should exhibit extreme work hardening behavior. Cold welding process. Cold or contact welding is a solid state process where joining occurs without fusion or heating of the substrate. So, here what happens? We have a you have a die or a moving plate, it can be fixed moving plate, it can be moving platen, it can be there. And then what happens here? We try to take these two close to each other and apply a huge pressure. This huge pressure leads to joining. Metal oxide layer exhibits on the surface, which is partially removed by cold working. So, that means to say when you go very close, you have a surface, just above the surface of the metal you will have an oxide layer. Now, this oxide layer is removed. When the oxide layer is removed, then the nascent layer comes in contact. When we apply pressure between these two, there is a joining happening. When two surfaces are pressed together, the oxide forms fragments and plastic deformation occurs, leading to metal contact and fusion. The ductility of the metal ensures a true fusion condition. Okay. So, the part to be welded are cleaned, then clamping of the die happens, then the forging force is applied such that they form the welding. So, here if you see, there is not heat applying, there is not much of heat which is dominating phenomena here. So, totally absence of applied heat is there, dissimilar materials can be joined. See, joining of dissimilar materials even today is a very big challenge. Thin, fragile metals can be joined. When you go to thick, it is very difficult. So, that is why people try to do cladding also. Dissimilar or disadvantages need a lot of surface preparation. At least one of the metals should exhibit ductility without excessive work hardening. So, the applications are manufacturing metal wires like aluminum, copper, gold, silver, platinum can be done. So, joining reels of continuous wire is done. Cladding and joining of metals are possible. The other welding process under solid state is diffusion welding process. So, diffusion welding is a solid state process where pressure is applied to clean work pieces at elevated temperatures below their melting point. You try to join these two. It is diffusion. Diffusion means why is heat used? Because there is a diffusion which is happening between the metal pieces. The bonding occurs through a mutual diffusion of atoms at the interface without macroscopic deformation or relative motion of the workpiece. Okay. So, a metal to metal contact is required. The temperatures up to 1100 degrees can be done. The atoms with the attractive force field forms a high strength. To prevent the contamination, the process is often conducted in vacuum. Diffusion welding process happens in vacuum. In electronic components, majority of the welding process happens by diffusion process. So, again all the advantages, disadvantages are listed. So, the most important applications are reactive components, rocket engine parts, rotor hubs, missiles, bombers, space shuttles. They all use diffusion welding process. So, in strategic application, diffusion welding process is very important. Why at all diffusion welding process? Because when you want to make a complex shape, you can't make it by any single manufacturing process. So, we make it piecemeal and joint. The next one is ultrasonic welding process. There is a fixed plate here. This is a fixed plate. The workpiece is held. The workpiece can be similar material, dissimilar material, thin material, slightly thicker. Thicker means I am talking about 3 millimeter, 4 millimeter. That itself is too large. We generally talk about 0.1 millimeter to 1 or 1.5 millimeter. So, this is one end. The other end is attached to a ultrasonic horn. This ultrasonic horn vibrates at 21 kilohertz with an amplitude of maybe 6 to 20 microns. Right. So, the top surface of the plate is pressed by ultrasonic horn. Ultrasonic welding is a solid state welding process wherein the coalescence is produced between a wide range of similar and dissimilar material combination by a local application of high frequency 21 kilohertz with a very short cycle time. Kilohertz are there. So, cycle time is very less. Then with an amplitude of 6 to 20 microns is applied. So, the surfaces are cleaned and then the nascent surface come in contact, the joining happens. Okay. So, the operation, the power supply converts the low frequency energy into a high frequency energy pulse. The pulse are transformed into a mechanical vibration by a transducer. So, once there is a vibration, there is a heat, the cleaning happens and the heating happens. So, diffusion happens. So, here is the clamping force. The clamping force is given by a mass. So, this is the holding, right. This is the reed, this is the wedge where you are trying to give a transducer which is ultrasonic. Then there is a vibration which is given. You can do it along the axis, horizontal to the axis, vertical to the axis, inclined at an axis. You can try all these things. So, transducer is kept, vibration happens. So, the weld tip is there. So, you have weldability, then there is an anvil. So, mass, anvil force is there. So, it is pressed to each other and then the welding happens. So, in the ultrasonic, power supply is very important, low frequency to high frequency has to be done. There is a transducer. Transducer is basically a piezoelectric material, we will see that, a coupling system and a clamping system. So, these are all the parts of welding equipments. Like in your AC power supply, you have a transformer. We are also trying to look at some details of the welding equipment. So, the power supply which is responsible for converting 50 or 60 hertz to a very high frequency of 21 kilohertz. So, it is done by a function generator and an amplifier. In the function generator, you can also try to have wave patterns. See, the function generator will do something like this. It is activated. Now, these are all square pulse. So, you can also try to have sawtooth you can try to have like this, tuck, whatever, you can try to change like this, or you can also try to change and play with it. You can also try to have something like a trapezium type, that is also possible. So, this is one square you can have, rectangle you can have, triangle you can have. So, you can start like this and try to have triangle types. Right. These are all different wave patterns which are generated by the function generator. The amplitude is only 6 to 20 microns. So, the frequency generator used for various welding operations are capable to operate between 10 hertz to 75 kilohertz. The role of the transducer is to convert electrical energy from the power supply into mechanical energy. This is done by the piezo crystals. The piezo crystal which is there. So, you apply voltage, it expands. So, now the piezo crystal can be oriented in many directions. You can do it perpendicular, you can do it along, you can cut the piezo crystal at an angle, so that you get whatever you want. So, piezo crystal is used, the same piezo crystal is also used for force measuring. So, in force measuring, mechanical is converted into electrical, here electrical is converted into mechanical. The coupling system transmits the high frequency vibration from the transducer to the workpiece. It is here we used the horn. So, what happens is, this is a function generator. The function generator is attached to a horn. This is called as the horn. This is the function generator, or these are piezo crystals material, right. Why is there a horn? Because this horn tries to amplify the small signal whatever is there to a large amplitude. So, the coupling system transmits the high frequency vibration from the transducer to the workpiece. So, the advantages are no critical surface preparation is required, joining of dissimilar is possible, short weld cycles, low power consumption are the advantages of it. So, joining of electrical and electronic components, thermatic sealing of material and devices, welding aluminum wire and sheet, and fabrication of nuclear fuel elements can happen under the ultrasonic welding process. The other process which is completely different is explosive welding process. In explosive welding process, what we do is, we try to keep dissimilar materials. So, you can see here, this is a parental plate, this is a fly plate. Okay. Fly plate is there are two plates, that is base plate or one metal, and this can be the other metal. Okay. Same material or dissimilar material. So, now on top of this fly plate, we try to keep an explosive. In explosive, what happens? It tries to create a pressure wave. When it explodes, it creates a pressure wave. This pressure wave is kept inside a container or something. So, the wave is tried to push the flyer plate against the parental plate. So, there is a settlement which is happening between the flyer plate and the parental plate. This leads to joining. So, here it will be by and large surface joining, surface to surface. Is a solid state welding process wherein a coalescence is affected by a high velocity movement produced by a controlled detonation. So, this is a very powerful process. Generally, people try to use it for a very large surface, and a very complex surface. If you want to cover it, they use this explosive welding process. Welding is achieved by detonating an explosive layer on one piece, generating kinetic energy that causes plastic deformation and removes surface contamination, resulting in a high quality joining. So, this is again used in aerospace industry. Weld heat metals without affecting the microstructure and the bond layer surface is achieved, because we are able to join this. The disadvantages: the use of an explosive is restricted in industrial area. Joining of dissimilar materials, die-cast components, and fabricated heat exchangers and pressure vessels are also tried. Cladding of pipes and tubes are also possible. So, pipes, so you have a large area pipe, then you have one another large area pipe. Suppose let us assume this is one pipe, this is the other pipe. So, you want to do pipe to pipe joining. So, many a times we try to expand this pipe and push this. When if it is a long pipe, it is very difficult. So, what we do is we keep this like a loose fit, this is pushed into it, and then inside it we keep an explosive, so that it pushes it and then it tries to join. So, dissimilar pipe joining is very efficiently done here. Next is friction welding process. Friction welding is also an inertia welding, is a solid state welding process, wherein which two cylindrical parts are brought together, causing a high friction. So, high friction you can try to rotate also. Two cylinder parts are brought in contact with friction pressure, causing the heating and forming the joint with pressure is applied. So, you can either try to have this way pressure, or you can try to rotate one is constant, the other is rotating. This also creates friction. The friction creates heat, that is why it is called as friction welding process. The heat is created, then pressing is happened. So, no foreign element is attached or added to it. The joint strength depends on the axial speed and the axial force. So, you apply force, you rotate. The combination is very much talked about. You can try to have solid workpiece to be welded. You can also have tubes to be welded. Tube welding of dissimilar materials possible. The method eliminates the need for a filler metal, flux or a shielding gas, and is ideal for butt welding of round bars or tubes. So, the principle is, first you have a right part, left part, the rotation happens in the left part. So, it is brought in contact with the right part, and parallelly you also apply a pressure, and then when the pressure keeps on be increasing, there is a flash which is getting formed. This flash we saw in flash butt welding, this flash is getting formed, and here you can see here the joining is happening and the flash projection happens. So, now later we can trim this portion and then make this dissimilar joining. So, the entire process whatever I discussed here is given in detail. Rotation, then you try to press it, then pressing will increase, then there is a flash happening, joining happens, friction. So, twist drill bits, gas turbine shafts, refrigerator tubes, sintered products, string column, aero engine drive shafts and valves. All these things are joined by friction welding process. If you have ceramic to metal joining, friction welding process can be thought of. If there is a twist drill, HSS material, or this is a tungsten high strength material, high wear resistance material, the shank where we hold in the sleeve is such to be a soft material. So, these two can be joined by friction welding process. Gas turbine shafts, yes, and then refrigerator tubes are also done by friction welding process. Forge welding process, and here interestingly in friction welding you can also have two plates here, right, and then you can have a tool. I am drawing the plan view, this is workpiece, this is workpiece, it can be similar, dissimilar. Here is a tool, I am drawing the plan view. So, the tool rotates and then it is moved inside the two metals. So, now this rotating tool creates a friction between these two plates, and then you try to have a joining. Here is the joining. So, this is also friction, this is called as friction stir welding process. So, wherein which it is stirring action happens by the tool and friction is introduced by the tool when it comes in contact with the workpiece, and that helps to soften the material and then you try to join them. So, this is also part of friction welding process. Now, moving to forge welding process. Forge welding process is one of the oldest welding methods in solid state welding. The surfaces are joined or heated till red hot and then forced together by hammering. So, you keep a base plate, you heat it, then you forge it. So, you can keep a die and do it, or you can keep a hammer and do it. So, this is how it is done. If you see the olden day wooden carts, you have a wooden wheel and then on top of it there is a fit, shrink fit which is done of a metal ring to reduce the wear. Wooden wheel, on top of it you will have a metal ring. So, there also what they do is they do forge welding process. It is a shrink fit, but they do a forge welding process for joining at the edges. So, the process is carried out by heating the component to be joined to a plastic state and a blacksmith forge with the upset edge. the hot workpiece are withdrawn in appropriate time and the joining is done repeatedly by doing it. Borax in combination with ammonic is the most commonly used flux in forging process. Railroads, general repair of shops, manufacturing pipes from rolled plates, metal art pieces and welded tubes are all part of forged welding process. Thermochemical welding process. So, here it is thermochemical. So, there is a heat, there is a chemical phenomena happening. So, the thermit welding is a method of uniting iron or steel part by surrounding the joint with steel at sufficient high temperature to fuse the adjacent surface of the part together. So, here the chemical components are mixed, you bring the two metals together, there is a reaction and this reaction forms the joining. Thermit welding is based on casting and forging practice and consists essentially of providing by means of chemical reaction a volume of molten weld metal which is poured into the joint by the welding. So, you try to take a container outside, do the chemical heat trying to explode or create a reaction, liquid is formed, you pour like casting. The chemical or thermit reaction takes place between the metal oxide and a metal reducing reagent. The chemical affinity of aluminum for oxygen is the basis for the thermit process. Thermit reactions is exothermic in one. So, what we do is we have a hopper wherein which we fill with aluminum, then we have an aluminum oxide. So, you try to here there is a reaction which is happening. So, the aluminum whatever is there, you have iron oxide. So, let me explain. So, it is aluminothermic reaction process is shown here. You have a railway track, then we have aluminum which is there. The aluminum melt, aluminum will always have a oxide on the top. So, this is a pot wherein which the melt is happen and then you have iron oxide and iron mold is also used. So, the mold is to make sure that it tries to guide to the, it is like a gating system, it tries to guide the material to the portion. So, if you see here the aluminum is on the top, aluminum oxide, iron thermit is here. So, it melts and it pours down and then it tries to fill the entire region. The aluminum whatever is there, when once the filling happens, whatever is the aluminum and aluminum oxide where reaction happened, that will try to be oozed out and gone. So, 2Al plus Fe2O3 gives you 2Fe, Al2O3 plus Q, right. So, this is the reaction. You can try to see there are similar other reactions also possible. You can try to have Fe3O4, 8Al gives you 9Fe plus 4Al2O3, right. So much of heat is released. So, the Fe2O3 plus 2Al forms 2Fe, Al2O3 and it forms this compound. Amandeep, these corrections have to be done, be very careful. So, this is how it is done and here is a video which shows that. So, we have a railway track on top and bottom and then the front side and then this is railway track. So, we try to react the reaction and the liquid is poured at the joints. So, you try to get it and then keep moving. A pattern is encased in a sheet iron oxide with sand packed and ramped around. After curing, the heating gates and the riser are prepared and the wax is melted and drained by the flame heating. The raising the part temperature, thermit mixture in a crucible is ignited, producing a heat of so much and then the molten iron and the iron oxide slags are formed. The molten iron flows in the mold, flushing the part and forming the thermit welding process. So, whatever we have said, it is clearly put in this figure or clearly placed in the figure. So, advantages, disadvantages. Here the biggest advantage what I see is you do not need a power supply and depending upon the thickness whatever it is, you can try to pour material accordingly. The disadvantages, it is applicable only for ferrous parts. It is high setup and cycle time. The process is uneconomical if we use to weld cheap metals or lightweight material. So, this is the application of thermit welding. Hopper is there and the clamps are there, they do it. So, radiant energy welding process. Laser beam welding. a laser, a light amplification by stimulated emission of radiation, laser, L-A-S-E-R. We will see the lasing effect later when we go through the machining part. Beam welding process is the focusing of monochromatic light into extremely concentrated beam. So, there is a huge heat flux which comes and hits, and then there is a melting happening. It employs a carefully focused beam of light that concentrates a tremendous amount of energy on a small area to produce fusion. So, the laser beam process comprises of the following: electric storage unit, capacitor bank, a triggering device, a flash tube which is there, then focusing lens and work table. So, all these things are equipments which are part of laser. So, when the capacitor bank is triggered, the energy is injected into a wire surrounding a flash tube, creating imbalance in the material inside. So, here we are talking about a tube. There is a capacitor bank. So, you have capacitor. Okay. In this capacitor, high energy is stored, there is a discharge. So, there is a gas which is passing through. This is gas, this is capacitor. When a capacitor bank is triggered, the energy is injected into the wire surrounding a flash tube, creating imbalance in the material inside. So, a gas, I have written it as gas. So, you can also have wire. So, there is a discharge, there is an imbalance. Thin xenon is often used to produce high power level for brief period. So, during the discharge, the energy level goes very high. A flash tube operates at thousands of flashes per second, efficiently converting electrical energy into light, which pumps the laser. Right. So, now the gas which is there, the gas is excited, and then it tries to have excited electrons which are there. The laser beam is then focused on the workpiece where fusion occurs is made. Both Nd:YAG laser and CO2 laser may be used for welding. CO2 laser is gaseous welding, solid state welding is Nd:YAG laser. Since Nd:YAG is pulsed, it is used for producing spot and seamless. CO2 is continuous. So, why are they talking about pulse and continuous? Is pulsed laser have very high energy density, because pulsed means you are trying to pulsate. So, this is the energy, this is the time. So, it goes flat, you have a peak, then it comes down, then it goes for a peak. So, these are pulsed one. Right. When you talk about continuous, the energy is constant with respect to time. E. So, here you have peak powers which are very high. So, that is why they are used for spot and seam welding. CO2 laser, majority of the time, or 99% they have a continuous laser with a constant energy. The energy efficiency of CO2 is lesser than the Nd:YAG laser. So, this is the flash tube which we were discussing, flash tube. Then we have a trigger device, right? Wire is there, a trigger device is there. So, here what we do is the flash tube surrounded by a coil. So, that coil creates the excitement inside the lacing material. Now, the lacing material is excited, and here we have partial. So, this is 100% reflecting surface. Here we have partial reflecting surface, 99% reflecting surface or 90% reflecting surface. So, moment there is a critical energy there. So, then it gets released, and this forms the laser beam. The laser beam is broad. So, you put a focusing lens to focus it on a smaller spot. So, whatever comes out of this is a coherent monochromatic beam. So, this tries to hit at the workpiece and the table is joining there. So, if you want to see the picture wise, this is what it is. So, you have a laser nozzle. So, then you have a laser. So, a shield gas is given, so that the oxidation and other things are not formed. So, if you want to add a powder, you can add it, or without adding a powder, if you want to join, you can join. Like in welding, you have a weld beads are formed, and then these weld beads, they try to dictate the microstructure and the quality of the joining. Okay. So, this is laser beam welding. More details about laser we will see during machining process. So, again advantages and disadvantages are given. Used for cutting and welding metals like copper, highly conducting materials can be easily done. So, this is how the machine at its focus looks like. So, you have two work pieces. So, laser comes and then there is a lasing action. So, heat is applied at the joining portion. So, the laser has a larger diameter as compared to that of electron beam. So, electron beam is also a similar process. Instead of light, here electron jet is generated. This electron jet is focused by electrical lenses. So, there it is optical, here it is electrical lenses. So, this will try to focus the beam and try to hit it on the workpiece. So, it hits on the workpiece, it has to be a conducting workpiece, or we try to give a coating on top of it and make it conducting, a thin layer, and then the joining happens. Electron beam welding uses a focused high velocity stream of electrons for deep fusion welding with minimal width, allowing the weld depth to exceed the width, depth to width. So, this is depth and this is width. So, very high aspect ratio joining has to happen. We use electron beam. So, the principles of operation: electron beam weld fuses base metal by directing a dense stream of high velocity electrons onto the workpiece. The process takes place inside a vacuum because electrons can be moved here and there by hitting at the air particles or molecules. So, we wanted to focus it. So, the entire operation is done inside a vacuum. So, you have a DC supply filament is there. So, the filament is excited by a very high current. So, then this in turn will emit the thermions. There will be filters. So, only electrons are extracted and it is pushed down further. The welding of automobile, aeroplane, aerospace, form and the other types of equipment including ball bearing over 100 millimeter thick, we use electron beam welding. Well friends, these are the references which we have used in preparing the slides. We have seen a spectrum of welding processes which will try to give you a feel what process, what do you choose and how do you choose. Thank you very much.